Welcome to this explainer. Today, we're going to completely demystify the invisible, lightning-fast infrastructure that actually powers the internet. We navigate to websites every single day, and it feels pretty much instantaneous. But right behind that action is this massively orchestrated global dance of servers, fiber optic cables, and protocols, all working together seamlessly. So what really goes down when you type a URL into your browser? Well, we are about to freeze time. We're going to track a single data request on what's basically a high-stakes relay race across the globe. From the absolute microsecond you hit enter to the moment a beautiful web page pops up on your screen, we'll see exactly how your device figures out where to go, how it asks for the data, and how that data makes its way all the way back to you. Okay, let's dive into this. It literally all starts with a super relatable human action, just hitting the enter key. That one single keystroke kicks off a crazy sequence of events involving your browser, your operating system, your internet service provider, and distant servers you'll probably never even see. Here's the roadmap for our micro journey today. First, decoding the URL. 2. DNS, the internet's phone book. 3. Packets, routing, and TCP. 4. The HTTP request. And finally, 5. The server responds. We'll take this chronological process one manageable step at a time. All right, step 1, decoding the URL. You know that web address you type into the search bar? It isn't just a name, it's actually a precise set of instructions. Let's break down the structure real quick. First up, we have the scheme, like HTTPS, which tells the browser, hey, make a secure, encrypted connection to the server. Next is the domain, something like jennapeterson.dev. That's the memorable address pointing to a specific server. Then we have the path, which is kind of like a folder structure on your own laptop, telling the server where to look. And finally, the resource, like Hello World, which is the exact file or content you want to look at. Every single piece tells the browser exactly how to connect and what to grab. Moving right along to Section 2, DNS, the Internet's phone book. So the crucial point here is that browsers can't actually route requests using human words. Computers communicate strictly using numerical IP addresses. Literally every single device on the internet, your smartphone, a massive data center, even your smart fridge, has a unique IP address to route traffic. But let's be real, we are terrible at remembering random strings of numbers. Without DNS, the domain name system, you'd be forced to memorize exact numerical sequences just to scroll social media or read the news. DNS is the internet's massive address book. It seamlessly translates those easy-to-remember domain names into the hard-pinging IP addresses that the machines actually need to connect. Now, finding that specific IP address is a fascinating 6-step relay race. First, your browser and OS check their local memory. If you've been to the site recently, boom, the IP is right there. If not, your internet service provider's DNS resolver steps in. It queries one of the internet's 13 root name servers, basically the master librarians of the web. That root server points to the top-level domain or TLD name server, which handles things like .coms. Then the TLD server points to the authoritative server, which holds the exact final IP address. Finally, that IP is sent all the way back to your browser. Now, you might be wondering, wouldn't querying master librarians and authoritative servers across the entire globe take forever? No way! This whole insanely complex DNS lookup process finishes in under 100 milliseconds. It is blazingly, invisibly fast. Okay, step 3, packets, routing, and TCP. So we have the destination IP address. But how does the data actually make the trip? Well, this quote brilliantly illustrates it. It is absolutely not a single stream. Data is chopped into tiny chunks called packets. It's kind of like tearing the pages out of a massive book and mailing them separately across different geographical routes. It sounds chaotic, but it guarantees network efficiency and resilience. Because if one piece gets lost along the way, you only have to resend that specific piece, not the whole book. Since these pages, actually let's call them packets, take totally different routes, they can show up completely out of order. Enter our protocols, TCP and UDP. TCP, the Transmission Control Protocol, is the meticulous manager. It perfectly reassembles our packets, making sure every single piece arrives in the exact right order. If something's missing, TCP notices and asks for a resend, making it perfect for loading websites. UDP, on the other hand, sacrifices perfection for pure speed. It blasts packets out as fast as possible and just drops lost data forever. That makes it totally ideal for live video streams or gaming, where speed is way more important than perfect accuracy. Which brings us to step 4, the HTTP request.
All right, so with a rock-solid TCP connection established to the server, the browser formally asks for the website. It builds a highly specific HTTP message made up of 3 parts. First, the request line, using methods like GET to say, hey, I want this data. Second, the request headers, passing along metadata to tell the server about your browser type or language. And finally, the request body. Now, this is usually empty if you're just looking at a page, but it contains data if you're, say, filling out a form or updating a profile.
Check out how beautifully clean this request line is. Get/hello world HTTP/1.1. Instantly, it tells the remote server exactly what resource the user wants, the Hello World page, and what language version they're speaking to get it.
And finally, Section 5, the server response.
So the distant server processes everything and fires back. And just like the request, this HTTP response is highly structured. It kicks off with a status line. Seeing a 200 OK status is the ultimate green light. It means everything works perfectly. Then, response headers give your browser exact instructions on how to handle the incoming data. Finally, the body delivers the actual goods, the HTML text, the CSS styles, or the images.
Now, what's really fascinating about this step is what happens next. The browser gets that first HTML file, but a modern web page is almost never just one file. As the browser parses the HTML, it realizes it needs way more pieces to build the page you actually see. So it instantly triggers a whole swarm of new, parallel requests back to the server to grab all the CSS styles, the JavaScript files, and the images. And there you have it. From one single keystroke to translating domains, chopping data into tiny packets, meticulously reassembling them, and making semantic requests, the whole shebang happening seamlessly. Next time you click a link and a web page loads instantly, I really hope you take a second to appreciate this invisible, lightning-fast miracle of engineering that we all use every single day. Thanks for hanging out with me for this explainer, and keep exploring.